everyone, welcome to my channel. So in this video I'm going to try to solve this problem, do some live coding work at the same time. I'm going to follow the general steps you should follow in an interview while trying to solve this problem. So let's go through this question. Given the head of the linked list, determine if the linked list has a cycle in it. So there's a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. So something like this. Return true if there is a cycle in the linked list, otherwise we are just going to return false. So here are some examples, pretty obvious. So let's see the constraints. So the number of the nodes in the list is in the range of 0 to 10k. Each node has a value between minus 100k to positive 100k. Pose is -1 or a valid index in the linked list. So actually it is going to be given the head of the linked list, so I think the pose is not going to be part of the input parameter. So let's see the definition. We have the node, it has a value, it has next pointer, so that's pretty much it. So how to find the cycle within the linked list? There's one thing I want to clarify is edge case checking. So for edge case, I can think about if the head is a non-pointer, then we just return false. That will be the edge case I can think about. Otherwise, it can be pretty much covered by our general algorithm. So let's see how to solve this problem in general. This is a pretty traditional thing, so there are two general approaches I can think about. One is we could have a hash set. So the hash set is going to contain all the nodes we have already visited. In case the node we are going to visit is within the hash set, then you're just going to return true because it seems like we have reached the same node another time. Otherwise, so the first one is hash set. So the next one is we can have a slow pointer and we have a fast pointer. So slow pointer, every time it moves, it is going to move by one node. Fast is going to move by two nodes. So if fast pointer reach the non-pointer, then we are just going to return false. Otherwise, if the slow pointer meets the fast pointer, then we are going to return true. So that's another solution, I would say. So considering the second one is more fancy, I think. Let's just do some coding work on top of this one. So let's have the edge case checking at the beginning. If head is equal to non-pointer, then we are just going to return false. Otherwise, we are going to have a list node. One is called slow, and one is called fast. So every time we are going to just say, okay, while fast is not equal to a non-pointer, you're going to say, okay, slow is equal to slow.next, and the fast is equal to fast.next. If the fast pointer is equal to a non-pointer, then you're just going to return false. Otherwise, we are going to have fast as equal to fast.next. So the thing here, if slow is equal to fast, then we are just going to return true. Otherwise, we return false. And that's pretty much it. Let's try to run this piece of code. I'll just rely on this platform to help us do the testing work. Alright, so it seems to be good. Let's run some other example. Okay, do a submission. Alright, so that's pretty much it for this question. So if you have any question regarding the solution or regarding this piece of code, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.